String literals. A string is a sequence of bytes or characters enclosed within either single quote or double quote characters. And this is an example similar to JavaScript. We have inside single quotes a string, then we have inside double quotes two words, that is another string. Quoted strings placed next to each other are concatenated to a single string. The following lines are equivalent. So inside the single quotes we have two words, a string, and then we have here inside single quotes the letter A, then we have inside single quotes just empty, and then inside single quotes we have the word string. If the NC underscore quotes SQL mode is enabled, string literals can be quoted only within single quotation marks, because a string quoted within double quotation marks is interpreted as an identifier. A binary string is a string of bytes. Every binary string has a character set and collation named binary. A non-binary string is a string of characters. It has a character set other than a binary and a collation that is compatible with the character set. For both types of strings, comparisons are based on the numeric values of the string unit. For binary strings, the unit is the byte. Comparisons use numeric byte values. For non-binary strings, the unit is the character, and some character sets support multi-byte characters. Comparisons use numeric characters code values. Character code ordering is a function of the string collation. For more information, you can check out the section 10.8.5, the binary collation compared to _being collations. Okay, we have a note here within the MySQL client. Binary strings display using the hexadecimal notation depending on the value of the double hyphen binary hyphen as hyphen hex. For more information, you can check out this link. A character string literal may have an optional character set introducer and collate clause to designate it as a string that uses a particular character set and collation. So here they give us this example. Inside of the brackets we have underscore char set underscore name, and then we have inside single quotes string, and then we have inside the collation underscore name inside of these brackets. And this is the example. For we have the select underscore Latin 1, and then the string inside of the single quotes we ended up with a semicolon. We do the next example, a select space underscore binary, and then we have inside single quotes string we ended up with a semicolon, select space underscore UTF 8MB4 single quotes string space collate space UTF 8MB4 underscore Danish underscore CI, and we ended up with a semicolon. You can use the uppercase letter L and then with this literal here inside of the single quotes, or lowercase m literal to create a string and the national character set. These statements are equivalent, so we have the uppercase letter select, uppercase letter M, and then single quotes. Inside of the single quotes on text, select, and then lowercase letter m. Inside of the single quotes on text, select underscore UTF 8, and inside of the single quotes on text. For information about these forms of string syntax, you can check out the section 10.3.7, the national character set. Within a string, certain sequences have a special meaning unless no backslash escapes SQL mode is enabled. Each of these sequences begin with the backslash, known as the escape character. MySQL recognizes the escape sequences shown in table 9.1 special characters escape sequences. For all other escape sequences, backslash is ignored. That is, the escape character is interpreted as if it was not escape. For example, we have the backslash x and it's just x. These sequences are case sensitive. For example, the backslash lowercase letter b is interpreted as a backspace, but the backslash uppercase letter b is interpreted as the letter b, just uppercase letter b. Escape processing is done according to the character set indicated by the character set connection system variable. This is true even for strings that are preceded by an introducer that indicates a different character set, as discussed in the section 10.3.6, character string literal character set and collation. And here we have this table, special character escape sequences. So we have two columns, the escape sequence, and then the second column we have the character represented by the sequence. So backslash 0, an ASCII null, and parentheses we have uppercase letter X inside of the single quotes, double 0 character, backslash single quote, a single quote character, backslash double quote, a double quote character, backslash lowercase letter B, a backspace character. Then we have the backspace lowercase letter N, a new line feed character, backslash lowercase letter R, a carriage return character, backslash lowercase letter T, a tab character, backslash uppercase letter Z, ASCII 26 control plus Z. See now the following tables, and then we have double backslash, a backslash character. We have the backslash, the percentage sign, a percentage character, C note following the table. Then we have the backslash underscore, a underscore character, C note following the table. So the ASCII 26 character can be encoded as backslash lower uppercase letter C to enable you to work around the problem that ASCII 26 stands for n-off-file on Windows. ASCII 26 within a file causes problems if you try to use MySQL space db underscore name, and then you would have your file name. The percentage, the backslash percentage sign, and the backslash underscore sequences are used to search for literal instances of the percentage sign and the underscore in pattern matching contexts where they would otherwise be interpreted as wild characters. See the description of the like operator in the section 12.8.1 string comparison functions and operators. If you use the backslash percentage sign or the backslash underscore outside of the pattern matching context, they evaluate to the strings backslash percentage sign and backslash underscore, not the percentage sign and the underscore. There are several ways to include quote characters within a string. So here we have a single quote inside of a string quoted with a single quote may be written as the just two single quotes here. A single double quote inside of a string quoted with a double quote may be written as double quotes here like this. Precede a quote character by an escape character, so this is an escape character. A single quote inside of a string quoted with double quotes needs no special treatment and need not be double or escape in the same way. Inside a string quoted with a single quote needs no special treatment, and we're going to see the example. The following select statement demonstrate how quoting and escaping works. So we're going to try it out. I'm gonna open the Windows PowerShell. So I'm gonna log in with my credential. It's gonna be MySQL hyphen -u, and then it's gonna be root. This is your username, and then space -p is gonna prompt you for your password. So we're gonna enter our password, and okay, let us in. So what we are gonna do right now is we are gonna type in uppercase letters select, and inside of the single quotes we're gonna type in just hello, comma, we're gonna separate it. Now it's gonna be inside single quotes. So we have inside of a single quotes we're gonna have double quotes, and inside of those double quotes we're gonna have this word hello, comma, and now we're gonna have single quotes, and inside of the single quotes we're gonna have double quotes, and inside of the double quotes we are gonna have another set of double quotes, and we are gonna have the word hello like that. And then we're gonna have let me see, what do they have here? Okay, it's gonna be hell, comma, and then it's gonna be just low like that. So okay, they are doing it without a comma and there is no space. Okay, that's fine. So here is gonna be a comma, and we're gonna inside single quotes here we're gonna have a backslash, and then just another single quotes. Let me see, it's just gonna be hello like this. Let me see, and we don't need this single quote here like that, and then we're gonna end it with a semicolon. So Okay, so pretty much we have that. Let me see if we are right. So okay, let me see, let's try it out. And this is what we have here. So we have hello. Okay, this one we have hello without single or double quotes. Then we have hello here inside double quotes. We have hellos inside two double quotes. So we have hello inside of the double quote, inside of the double quote. Then we have hello. We have just this single quote separating the hell and the low, and then we have one single quote hello. So we have that. Now we can pretty much, let's just grab this one since to save some time, and let's just copy and paste it. So let's just paste it here, Control C to copy and Control V to paste it. So let's try it out. And now we have, let me see, what do we have here now? Okay, so what we have is hello without single or double quotes. Then we have hello inside single quotes. Then we have hello inside single quotes, and then we have hell double quotes low, and then double quotes hello. Why? Because the first one we wrote it inside double quotes, so that is the reason that it appears like that. The second example, we first wrote or type double quotes, and inside of the double quotes we pass in a string inside of single quotes hello. That is the reason we have hello but inside single quotes. Then we have double quotes first, and then single quotes, and then inside of the single quotes we have another single quotes with hello. That is the reason that we have two single quotes here. And then we have the inside double quotes the word hell, so that is the reason that we have here. And then we have double quotes the word low, so that is the reason that we have here. And then we have inside of the double quote we have the backslash, and then one single double quote with hello. That is the reason that we have the double quote here. So we have that. Now let's try with let's just type it in. So let's try this one. It's gonna be select, and it's gonna be single quotes. We're gonna end up this statement with a semicolon, so it's gonna be this backslash, it's gonna be n s backslash n, it's gonna be 4 like that, backslash n, and then it's gonna be line, so like this. So we have select inside of the single quotes, we are writing this, and then we're using the backslash n. Then it's gonna be s backslash n again, 4 backslash n again, line. So let's try it out, and let me see. As you can see, this is 4 lines. This is 4 lines, as we can appreciate here. Now we can pretty much also type in select, and inside single quotes we're gonna end it with a semicolon here, and then it's gonna be this okay, this appearing like this. Then it's gonna be backslash, and then it's gonna be backslash like this. And let me see, we have disappearing backslash, so we have select, disappearing, and then backslash. Okay, so we have that. To insert binary data into a string column, such as a blab column, you should represent certain characters by escape sequences backslash, and the quote character used to quote the string must be escaped in certain client environments. It may also be necessary to escape null or control plus Z. The MySQL client truncates quoted strings containing null characters if they are not escaped, and control plus Z may be taken for n-of -file on Windows if not escaped. For the escape sequences that represent each of these characters, see table 9.1 special character escape sequences. When writing application programs, any string that might contain any of these special characters must be properly escaped before the string is used as a data value in an SQL statement that is sent to the MySQL server. You can do this in two ways. So process the string with a function that escapes the special characters. In a C program, you can use the MySQL underscore real underscore escape underscore string underscore quote with double quotes. I mean with open and close parentheses. Uppercase letter C API function to escape characters. We see the MySQL underscore real underscore escape underscore string underscore quote open close parentheses within SQL statements that construct other SQL statements. You can use the quote function. The parallel DBI interface provides a quote method to convert special characters to the proper escape sequences. See section 29.9 MySQL parallel API. Other language interfaces may provide a similar capability. As an alternative to explicitly escaping special characters, many MySQL APIs provide a placeholder capability that enables you to insert special markers into a statement string and then bind data values to them when you issue the statement. In this case, the API takes care of escaping special characters and the values for you. So that's what we have for the string literal. So let's check out the next section, and the next section is the numeric value. So let's just click here, next. Okay, so we have the numeric values. Number literals include exact value integer and decimal literals, and approximate value floating point literals. Integers are represented as sequence of digits. Number may include that as a decimal or just the point as a decimal separator. Numbers may be preceded by the minus or plus to indicate a negative or positive value respectively. Numbers represented in scientific notation with mantissa and exponent are approximately hyphen value numbers. Exact valued numeric literals have an integer part or fractional part or both. They may be signed. Examples are 1, 0.2, 3.4, -5, -6, 0.78, plus 9.10. Approximately value numeric literals are represented in scientific notation with mantissa and exponent. Either or both parts may be signed. Examples are 1.2 E3, 1.2 E minus 3, negative 1.2 E3, and negative 1.2 E negative 3. So two numbers that look similar may be treated differently. For example, 2.34 is an exact value fixed point number, whereas 2.34 E0 is an approximate value. So it's a floating point number. The decimal data type is a fixed point type and calculations are exact. In MySQL, the decimal type has several synonyms: numeric, decimal, fixed. The integer types are also exact value types. For more information about exact value calculation, you can check out section 12.24 precision math. The float and double data types are floating point types and calculations are approximate. And MySQL types are synonyms with float or double are double precision and real. An integer may be used floating point context. It is interpreted as the equivalent floating point number. So that's what we have for the numerical literals. And finally, we're gonna see the next section, that is gonna be the date and time literals. So here we have the standard SQL and ODBC date and time literals, string and numeric literals, and date and time context. Date and time values can be represented in several formats, such as quoted strings or as numbers, depending on the exact type of the value and other factors. For example, in context where MySQL expects a date, it interprets any of the, well, we have this inside single quotes 2015 -07 -21, so it means the 21 of July of 2015. And we have it in another way, single quotes and just the number 2015 07 21, and also without the same number but without the single quotes as a date. This section describes the acceptable formats for date and time literals. For more information about the ternary data types, such as the range of permitted values, see section 11.2 date and time. Data types: standard SQL and ODBC date and time literals. Standard SQL requires temporal literals to be specified using a type keyword and a string. The space between the keyword and a string is optional, so we have this date here, and inside of the single quotes we have the str, we have the time, again a space, and inside single quotes str, then timestamp, space, and inside single quotes str. MySQL recognizes, but unlike standard SQL, does not require the type keyword. Applications that are to be standard compliant should include the type keyword for temporal literals. MySQL also recognizes the ODBC syntax corresponding to the standard SQL syntax. So inside of the curly braces we have the D space single quotes std str. We have in the next example, in the curly braces we have the letter T space single quotes str, and finally inside the curly braces we have the TS space inside single quotes str. MySQL uses the type keywords and the ODBC constructions to produce datetime and datetime values respectively, including a trailing fractional seconds part if specified. The timestamp syntax produces a datetime value in MySQL because datetime has a range that more closely corresponds to the standard SQL timestamp type, which has a year range from the 0001 to 9999, so to the 9999. The MySQL timestamp year range is 1970 to 2038. String and numeric literals in date and time context, and we're going to see some example right now. MySQL recognizes date values in these formats as a string in either, so inside of the single quotes we have the year month date or the year month day format. And the difference is, for example, we'll put here 2023 the year, so 4 digits, but in this one we only put 2 digits, that will be just 23. So this is the format. A relaxed syntax is permitted but is deprecated. Any punctuation character may be used as a delimiter between date parts. For example, inside the single quotes we have 2012, 12, and then 31, separated by the hyphen or the dash. And in this part we have the single quotes. Inside the single quotes we have the year 2012 slash 12 slash 31, and the next one we have the single quotes 2012, the caret sign 12 caret sign 31, and also we have inside single quotes we have the year 2012 at 12 at 31 are equivalent. Beginning with MySQL 8.0.29, using any character other than the dash as the delimiter raises a warning as shown here, so we can check it out. You can just copy and paste this example if you want. I'm just gonna type it in. So we're gonna type in select, and it's gonna be select date, and we're gonna type in single quotes, and then we're gonna end this statement with a semicolon. Inside the single quotes we're gonna type in 2012, and it's gonna be at 12 at 31. So let's click enter, and the date is 2012 dash 12 dash 31, so it means the 31 of December 2012. So that's what we have here. We can also show a warning, so let's do that. It's gonna be show warnings like that, backslash in uppercase letter G, and what we have here is level warning code for 1095 message delimiter at and position 4 and datetime value. So we have 2012 at 12 at 31 at row is deprecated, preferred standard dash. So instead of this at character they prefer the dash. This is what we have here as a string with no delimiters in either the year month date with 4 digits or the year month date with day with 2 digits format, provided that the string makes sense as a day. For example, here we have 2007, 05 would be the month, and 23 the day obviously, and then we have 07, 05, 23. So this is more ambiguous, but are interpreted as 2007, 05, 23. This is the first one, but 071332 is illegal. It has nonsensical month and day parts. It becomes pretty much this year, month, and date, that is just a bunch of zeros, as a number in either the 4-digit year, month, day, or the 2-digit year, month, day format, provided that the numbers make sense as a day. For example, here we have 1983 0905, and then we have 83 0905 are interpreted as 1983, or just the 1983. The month would be 09, and then the day would be 05. Since we were using this format, the month would be the 09 and the day would be 05. MySQL recognizes datetime and timestamps values in these formats as a stream in either the year, month, and date. We also have the hour, the minutes, and the seconds, or the pretty much the year with 2 digits, the month, date, hours, minutes, and seconds format. MySQL also permits a relaxed syntax here. Although this is deprecated, any punctuation character may be used as a delimiter between day parts or time parts. For example, we have inside of the double quote, we have the 2012 12:31, and then the time 11:30:45. And also we have inside the single quotes, we have the 2012 $12 $31 space 11 plus 30 plus 45. And also we have inside single quotes the 2012 /12 /31 space 11, then the asterisk 30 asterisk 45, and the 2012 at 12 at 31 11 $30 $45 are equivalent. Beginning with MySQL 8.0.29, use any characters as delimiters in such values other than the dash for the day part and the colon for the time permit raises a warning as shown here. And we can just try it out. Let's just copy and paste it, this one. So it's gonna be select timestamp, and it's gonna be inside of the single quotes. We're gonna have 2012 $12 $31 space 11 asterisk 30 asterisk 45, and this is what we have here right now. So we have the year, the month, and the day, and also the hour, the minutes, and the seconds. So we can also show the warning as we did earlier. We could just type it in, so we see the warning, and as you can see, the caret sign, okay, the message delimiter caret sign position 4 and daytime value at row 1 is deprecated. The preferred standard is the dash. Okay, that's fine. The only delimiter recognized between a date and a time part and a fractional seconds part is the decimal point. The day and time parts can be separated by the uppercase letter T rather than a space. For example, we have the year 2012 hyphen or just dash 12 dash 31 space 11 :30 :45, and then inside of the single quotes we have again the year 2012 dash 12 dash 31 and then uppercase letter T 11 :30 :45 are equivalent. Previously, MySQL supported arbitrary numbers of leading and trailing white spaces characters in date and time values, as well as between the date and time parts of datetime and timestamps values. In MySQL 8.0.29, later this behavior is deprecated, and the presence of excess white space characters triggers a warning as shown here. So let's try it in. So as you can see, we have the select space timestamp blah blah blah, but here we have an space, so we have white spaces. So let's see what happens. And okay, so it's one row and it triggers one warning, as you can see here. Okay, it triggers one warning, and if you want to see the warnings you have to type it in. So let me see, like that. And here delimiter inside single quotes and position 11 in daytime value at row 1 superflow says deprecated. So we have that. What is this? Please remove. So pretty much they're telling you to remove these white spaces. So we have that. Also, beginning with MySQL 8.0.29, a warning is raised when white spaces characters other than the space character is used. So let's try it in. Let me see. So we can just copy this one, paste it here. So it's gonna be select, it's gonna be space timestamp single quotes It's gonna be here, and let's see what else here. What else do we have here? So let's end it with a semicolon. And okay, then let's just copy to the number, and we can just paste it here. And okay, so what happened here? Timestamp. Okay, let me see. Let's just let's just go here and let's just type it in, select, and it's gonna be timestamp, like that, single quotes, and it's gonna be 2021-06-06, like this. And okay, so then we're gonna have 11:15:25. We're gonna end it with a single quotes. We're gonna end it with a semicolon. And now we have here that it's gonna be the 2021 July 6th, and the time is gonna be 11 hours 15 minutes 25 seconds. So we have that, and also we can show the warnings. And let me see, since we have one warning, you can use show warning / uppercase letter G, and then here we have the limiter. Inside of the single quote we have the / lowercase letter n and position 10 and date time value. So we have that at row 1 is deprecated, so preferred standard is the empty single quote. So we have that. Only one such warning is raised per temporal value, even though multiple issues may exist with delimiters, white space, or both, as shown in the following series of statements. So let's try this one. Okay, so we have the select, timestamp, and we have single quotes, but we have some white space. Okay, so we have the year, we have also the time, but we have a warning, and again, pretty much is the white space. So let's see what is the warning. Okay, the limiter the limiter in position 4 and date value at row 1 is deprecated, preferred standard is the dash. Okay, so we have that. They didn't like this character, the exclamation mark. Okay, so what else do we have here? So let's try it with this example, and it's gonna be something similar. Let's paste it in, and we have one warning, so I can just show what is the warning. The limiter in position 11 and daytime value at row 1 is superfluous and is deprecated, so they didn't like that. Okay, and finally we're gonna use the correct one without the white spaces. So we click select, timestamp, single quotes, the year 2012-12-31, one space, and then the time at 11 hours 30 minutes 45 seconds, and it throws us no warning. So that's the correct way. As a string with no delimiters in either the year, date, month, hours, minutes, and seconds, format provided that the string makes sense as a day. So we have this example as a number in either the year, month, day, hours, minutes, seconds, format provided that the number makes sense as a day, for example. So you have that too with these numbers without colons or dashes, or so we have that. A daytime or time extents value can include a trailing fractional seconds part and up to microseconds, 6 digits precision. The fractional part should always be separated from the rest of the time by a decimal point. No other fractional second delimiter is recognized. For information about fractional second support and MySQL, you can check out this link. Dates containing 2-digit year values are ambiguous because the century is unknown. MySQL interprets 2-digit year values using this rule. So we have the year values in the range of 70 to 99 become 1970 to 1999. The year value in the range of 00 to 69 become 2000 to 2069. So that's fine. We can also see this section and 2-digit years and dates. For values specified as a string that include day part delimiters, it is unnecessary to specify 2 digits for months or day values that are less than 10. So here we have 2015-6-9 is the same as 2015-06-09. Similarly, for values specified as a string that include time parts, part delimiters, it is unnecessary to specify 2 digits for hour, minute, or second values that are less than 10. So we have 2015-10-30 space 1 colon 2 colon 3 is the same as 2015-10-30 space. The hour will be 1, the minute 2, and the second 3. So we have that. And what else do we have here? So we also have MySQL recognizes time values in this format, so you can check out this one.